This is video number 6 from digitaluniversity.org. We're going to try to present a whole series of videos where we develop different techniques for analyzing electrical circuits. For this video, what we want to do is just find the equivalent resistance of this circuit right here, where all of the resistors have the same value of 50 ohms. So when we look at this circuit, it's clear that these two resistors are in parallel, and these three resistors are in parallel. But what about this one here? Is this resistor perhaps in series with this resistor? But if we look at the circuit more closely, it should be apparent, hopefully, that that can't possibly be true. These are not in series because, for example, let's say we had a current that was entering the circuit from up here. It would be divided amongst these three parallel resistors. But here, after the current goes across this resistor, it could just simply take the path of least resistance to complete the circuit. So these are not parallel, or are not in series with each other. What perhaps is the relationship of this resistor with these two parallel resistors? And again, imagine if we had a current entering the circuit, it would get split amongst these three resistors. Now let's say the current that goes across this resistor, it reaches this point, and it could be split amongst these two parallel resistors, and it could also be split amongst this resistor. So this resistor right here is actually in parallel with these two resistors. So let's try to show that more clearly. Like this. So here's our circuit now. And let's consider these two parallel resistors. And what is their equivalent resistance? It's the product of them, R squared, divided by their sum, R plus R, or 2R. And that's just equal to R over 2. So these two have a parallel, or an equivalent resistance of 1/2 R, which means that we can replace these two resistors with a single resistor that has this value. So let's go ahead and do that. Here this is R over 2. And that one we don't need any longer. It's incorporated into this one. So now the circuit looks like this. Now, these are in series. This one is in parallel with these two series resistors. So let's redraw the circuit to emphasize that. We will write it like this. And then these two add together to give 2 times R. These two add together to give 3/2 R. And this is R. So now the circuit is reduced to this, and the total resistance, or the equivalent resistance of this, you know from video number 2, its reciprocal, is equal to the reciprocal of that resistor, 1 over 2R, plus the reciprocal of this resistor, 2 divided by 3R, plus the reciprocal of this resistor, 1 over R. And let's see what this gives us. Let's consider these two terms. Here we have 1 over 2R plus 1 over R. And that equals R plus 2R, and that's 3 times R divided by 2R squared. That is equal to 3 divided by 2 times R. So these two terms combine together to give us 3 divided by 2R. So let's write that in here. 3 over 2R. Okay, so let's see. This is equal to 9R plus 4 times R divided by 6R squared. This would be equal to 13 divided by 6 times R. And that's 1 over the equivalent resistance. So equivalent resistance is equal to 6 over 13 times R. And we stated up above that R equals 50 ohms. So our equivalent resistance equals 6 over 13, this reciprocal right here, times R, or times 50. So we have 300 divided by 13, and put that on the calculator, it's very close, 23 ohms, and then it comes out to 23, and it comes out to like 23.07, but round this off to 23, and our equivalent resistance comes out to be 23 ohms. And what the original circuit looked like, this was R. And we had another resistor up here like this. That was our original circuit. And then just by picking it apart, we see that the equivalent resistance comes out very, very close to 23 ohms. So anyway, that's it for this video. What we're going to do is I think we have 2 more videos. We're going to consider these types of problems. And then after that, we'll get into mesh analysis and node analysis. So come back and join us for those videos, and we'll see if we can solve some more problems.